I am Mohsen with student ID 220504534, and here I will show my project. This project aims to develop an artificial neural network model to predict employee salaries based on three features: years of experience, years of experience, and age and education level. So why this model? Predicting employee salaries is an important problem in human resource management. So, in summary, this project is employee salary prediction using artificial neural network. Now I will go over the dataset. So this is the dataset will be used. It has 1, 2, 3, 4, 5, 6, 7 columns. And about 400 rows. The every rows represent an employee, and every column shows the information such as age, gender, education level, and job title, years of experience, and salary. So this dataset contains information about salaries of employees of a company. Now I will go over the code. Here are some important libraries, and this function is used to convert the education level to a number, because as we see here, the education level is a string, so we use that function to convert it to a number between 1 and 2 and 3. Here we load the dataset and read them. So yes, this function is used to load the data and read the data. Here I am cleaning the data, cleaning the columns. Okay, and here I remove if there is a missing value. For example, if the age is missing, I remove that rows. Okay, and here I convert the data into numbers and store them as a list. Here I store them as a list, and the list has like four data: experience, age, and education, and salary. And I print here the valid data, the valid rows. Okay, and then I store them in, and I return the data list. And here is the normalization. Here I normalize the data using minimum maximum normalization. First I find the minimum, then I find the maximum for each column. Then I scale all values to be between 0 and 1 using this simple equation, and return the normalized data, normalized minimum and maximum. Here here is the denormalization. This function convert normalized value back to the original scaled to the original salary scale using the stored minimum and maximum values. Here I split the data into two groups: 80% for training and 80% for testing, and I return them. Here is the the activation function, sigmoid function, and here is the derivative of the sigmoid function, and this is the predict. This function takes new input values, normalize them, then performs a forward pass using the trained weight to predict the salary, then convert back the result to the original scale here. And now this is the main program. Okay, here I load the dataset, normalize it, and split. Here is the structure of the structure of the neural network, which has three input: 3 input, 5 neurons, hidden 5 neurons in the hidden layer, and then this is the learning rate, and this is the epochs, which is 1000. I will show how the neural networks look like. This is how the neural network looks like: 3 input, 5 neurons in the hidden layer, and 1 output layer. And then after that, I initialize the weights and biases randomly before the training. And this is the training part. So during the training, this is the training part. So during the training, the model repeat for 1000 epochs for each row. So it performs forward propagation. Here is the forward propagation. Then calculate the error. Then calculate the error. Then use back propagation to update weights. Use the back propagation to update the weights and the biases, and the loss is stored. And the loss here is stored to plot later to show the graph. And here is the testing graph. Only performs not testing graph, sorry, it is the testing part. Here I only performs forward propagation here without updating the weights. Then I compare the actual salary. Then I compare between the actual salary and the predicted salary. So I show them, I print them, the actual salary and the predicted salary, and then I calculate the error for each row and the average error. Yes. And yeah, here is the manual testing, and here is the graph. Now I will run the code now to show the result. Here is the graph. This graph shows the training loss over epochs. So as we saw here, the loss is high, but it decreases at the beginning. So the loss, it decrease over the training. So at the beginning it was high, then it start to decrease over the training. So this means the model is learning. And let me show the other output. So this is the test result. So here the dataset contains about 373 rows, valid rows, and training rows. Here is the training rows and the testing rows. Here the predicted salary. And this is the actual salary, and this is the predicted salary. Okay, and this is the error. Okay. Yes. So I compare between them, and I compare between these two, and I print the error. So what else? So this is the average error. It's about 13,000, which is reasonable. Yeah. As we see here, this model is able to capture the general relationship between the input and salary. Okay, and this is the manual testing. Here I test the model with new inputs. So I will show you when I increase. For example, I increase the input, and I will say for example, here the last one. So here it is 26,000. After I increase, I will show. Here, after I increase the input, the salary increased.